Alright, we're back at section 10.2, and we're looking at doing some graphing. We talked about the steps that were that I suggested that you use as far as graphing hyperbolas. So we're going to try to kind of run through those as we go. It says given x squared over 9 minus y squared over 4 equals 1. This, by the way, is referred to as standard form for the equation of a hyperbola. And also notice that the x squared is in the numerator of the first term, the positive lead coefficient. So that tells me that my branches are going to open to the right and to the left. That a squared is 9, that b squared is 4. Alright? Now it asks for us to graph the hyperbola, but to help us with the graph of the hyperbola, it would be nice if we could find the vertices, find the reference rectangle, and of course draw in our asymptotes, and we're going to have our equations of those as well. So in this problem, I'm going to do a little bit of B here first before I actually do this. I'm telling you that A is equal to 3 and B is equal to 2. Alright, so that tells me that since my center is at 0, 0, that I'm going to have vertices to the right and to the left of the center. And well, it says also to identify the center here, because it's x squared and y squared with no numbers being subtracted or added to them, that my center is going to be 0, 0, so I'll put that here as well, that my center is 0, 0. I'm not going to actually add that to my graph, although my asymptotes will go through that. My vertices are a units to the right, a units to the left, so that would be 3, 0, and negative 3, 0. So I'll graph those here and here. And then I also am going to use the fact that I know that B is 2, so these would be the endpoints here and here of my conjugate axis, which means that now I am going to, because of the inconvenience here of trying to graph on the whiteboard, I am going to be as careful as I can while I freehand, which I just told you guys not to do. I told you to get a ruler and be neat. I'm trying to be at least the neat part of it. That's a little shaky. Okay, that would be my representative rectangle. Now I am going to take my yardstick here and I am going to draw in my asymptotes here best I can. Now my asymptotes help me with my graph, but they're not actually part of my graph, so I'll make them dotted or dashed. Should have gone through the origin, but probably missed. Yeah, pretty close, kind of missed. With graph paper, you'll be able to see this a lot more readily and hopefully not have near the problems. Hope that didn't slide. I have a feeling it slid a little. Okay, so there are my asymptotes. So there are dashed lines. I put the arrows on the end to indicate that. I have my vertices. I have my representative rectangle for my asymptotes. I'm ready to try to make a sketch here, but again, to make the sketch, you're going to use the vertices. Your branches are going to open to the right and to the left, and you're going to use the asymptotes so that your curve will approach it. So best I can do is to indicate that kind of like that. You can put the little arrow on the end if you want to. Just make sure it's big enough that it can be seen. There you go. That wasn't as bad as I thought it might be. Oh, there we go. That one's not quite as good. Now if you're wondering, should we be plugging in points? Well, you can most certainly plug in points to help get a sketch, but I'm going to indicate to you here that you're going to have to be doing some fancy arithmetic. You can come up with a reasonable sketch if you follow those steps that I gave you. Now, I have the vertices, I have the center vertices foci. Well, I need to know what C is, not C the center, but the C value. And remember, for a hyperbola, a squared plus b squared is equal to c squared. So I have 9 plus 4 equals c squared. That means c squared is 13. C is equal to the square root of 13. So my foci are on the same horizontal axis here, the line that contains the transverse axis, and so they would be C0 and opposite of C0, or square root of 13, 0, opposite or negative square root of 13, 0. And the equations of my asymptotes, y equals plus or minus, I'll get 2 for 1 here, b over a, so plus or minus 2/3 x. And I am ready for the next example. That one wasn't so bad. Now in the next example, you may notice, even though it kind of went downhill a little bit here, that this is not in standard form. It's not set up equal to 1. I'll go ahead and write it out here. And to make this equal to 1, I'm going to divide through by 16, both sides, every term. And I have y squared over 4 minus x squared over 16 is equal to 1. Notice here in the first example, a was 3, b was 2, a was bigger than b, but in this example, a is 2 and b is 4. Because the a squared would be under the first term with a positive lead coefficient here of 1. So notice that the y squared is in the first term. That tells me my hyperbola is going to open upward and downward, right? And that a is 2, b is 4, and I'm able to start getting some information to go ahead and sketch this. So the center again, because there's nothing to add or subtract from your variables, your center is 0, 0. And I'm going to go a units above and a units below for my vertices. So a units above 0, 0 would be 0, 2, and a units below, or 2 units below, would be 0, negative 2. So my vertices are here and here. Okay? And I know that b is 4, so I can come up with my representative rectangle. So I'm going to go out to here and out to here, 1, 2, 3, 4. So it's going to kind of look like this. See if I can draw this neatly. Did an okay job last time. I think it's gone to my head. If I took the time to get my straight edge, I could make this a little bit more exact. But there they are, and my asymptotes are going to go through the origin and through those opposite vertices there. So let's see if I do this. You can see how badly I've done this. So it's going to go that's why you use a ruler when you make your representative rectangle. Do as I say, sometimes not as I do. This one's a little bit better. Oh, sliding. Now remember, this one opens upward and downward. And look at the big gap here. This is going to open very wide, upward and downward here. So let's see. Try to do the best I can. Now because this opens so wide and because my graph only goes out to about 8 in both directions, I'm not going to be getting that close to my asymptotes immediately. Probably more out here they're going to start to really get close. So the best I can do here is just kind of make it, well, make it bowl shaped here best I can. Well, I don't want it to look like it's coming back in. Yeah, that's about as good. Something like that. And let's see, we have center, we have vertices, we need the foci, so I need to know what C is. Well, there's A and B, 2 squared plus 4 squared equals C squared. So C squared equals 20, C is equal to the square root of 20, or 2 square roots of 5. So my foci are up here and down here. So they would be at 0, 2 square roots of 5, and at 0, negative 2 square roots of 5. And the equations of my asymptotes Not b over a this time, because it opens upward and downward. It's a over b, so it'd be 2 over 4, or a half, so I'd have plus or minus 1/2 x for the equations of my asymptotes. Now it gets more interesting, at least in my opinion it gets more interesting, when the center isn't always right at 0, 0. It gets a little bit more, there's a little bit more thought into it, but that's what makes it a little bit more interesting. So we'll do some of that in the next video.